go. We're going to talk about some Wi-Fi fundamentals as well. There's kind of a baseline of knowledge that you guys, or that I think is important to know to kind of operate Chanalyzer in the first place. Laughing at some of the chat here. And so we're going to talk a little bit about that, and then finally we'll get into Chanalyzer and then open up the floor for any questions you guys have. I know we kind of started a little bit late with those audio issues, so I'll try and kind of go a little more quickly than I normally would over these first parts. A little bit about myself. My name is Casey. I'm the CX specialist here at MetaGeek. I have a few certifications put on by the CWNP program, which I highly recommend to further your knowledge on Wi-Fi. You can also find me at Kathy_Fi on Twitter. There's a lot of really smart people on Twitter in the Wi-Fi community, and so I highly recommend checking that out as well if you have any questions regarding Wi-Fi. A little bit about MetaGeek. We're based here in Boise, Idaho. So it's 1 p.m. Mountain Standard here, and that's a screenshot from our office, but we're all working from home, of course, right now, and just hoping things get back to normal. Let's jump right into some Wi-Fi fundamentals. The very most important thing to understand is right now there's two bands that Wi-Fi operates in, and these are the two bands that Chanalyzer displays for you. There's the 2.4, and then there's the 5 gigahertz band. And I know a lot of you guys probably already know this, but the wavelength of the 2.4 gigahertz band is a lot longer than the 5 gigahertz band, right? It's about 5 inches here. And what this means is that this can basically attenuate, or this basically can pierce through walls a lot easier. It goes a lot farther. And so oftentimes you're going to see, Chanalyzer will show you networks in the 2.4 gigahertz range, whether they're your networks or neighboring networks, and you have a higher chance of seeing neighboring networks just because it travels so far. And it's really important to keep that in mind when you're thinking about output levels on access points. The 5 gigahertz band, on the other hand, is a lot shorter. It's about 2.4 gig. Well, it's about 2.5 inches actually. Long here, and so that means that walls and materials stop the signal a lot more, and so usually it's kind of harder to see your neighbor's 5 gigahertz networks just because there's so many walls in between you and your Wi-Fi scanner or your computer. So kind of important to keep that in mind. And of course, most devices are compatible with the 2.4 gigahertz band. There's not all devices are compatible with the 5 gigahertz band, although that's changing. So just kind of important to understand that there's only 3 non-overlapping channels in the 2.4 gigahertz band. There's going to be a lot of noise here, and I'll show you that and how Chanalyzer displays that. Whereas the 5 gigahertz band, there's a lot more room down there, and so usually there's not as much interference or noise. You're usually going to be spared there. Just a quick bit on the standards. Really the important takeaway from this slide, this kind of goes over the history of Wi-Fi and the PHY types that were released. The important takeaway here is the modulation scheme. So this DSSS modulation scheme. This was the very first scheme that they used in 97 and 99. And what this looks like on a spectrum analyzer, and I'll show you this in a bit, is more of a curved shape, kind of like this, about 20 megahertz wide, but it's curved shape. And then once we got into OFDM, which stands for orthogonal frequency division multiplexing, this basically looks more like a square haystack shape, kind of like this on a spectrum analyzer. And so when you see these two different shapes, you kind of start to understand what data rates are being used. If you see that square kind of haystack shape, you know that at least 54 megabits per second are being used or higher, which is good. Those are high data rates. If you see this kind of more curved shape, this DSS curve shape, you know that more basic data rates are being used. Typically, you will only see this in the 2.4 gigahertz band, but I'll kind of show you some examples. Hopefully my current environment has some people using those lower data rates in my neighborhood. Just a quick bit on Wi-Fi interference. I think this is important to understand and to know. That there's co-channel interference, which means that all your Wi-Fi devices and your networks, they're sharing the same channel. This could even be your neighbors sharing the same channel. And then there's adjacent channel interference, which means your neighbors are using different channels that are adjacent to the one that you're using, and therefore their client devices are using those channels. In the world of Wi-Fi, it's best to have co-channel interference. This is because Wi-Fi devices are very polite. They take turns to talk when they see that another channel or that another device is on the same channel as they are. Whereas they don't have that same level of politeness when there's adjacent channels and they start yelling over each other, and that noise floor starts to get higher and higher. And so, this is kind of a, for a lot of beginners, it's a hard concept to understand, but it's still better. If your neighbor is on channel 6 and you have, neighbors on channels 1 and 11 as well, it's best to share either 1, 6, or 11 with those neighbors as opposed to trying to fit an adjacent channel like 4 or 7, right? It's best to actually share that with your neighbor than be adjacent to it, just so that your Wi-Fi devices and your neighbor's Wi-Fi devices are being a little more polite with each other as opposed to trying to yell over each other. Now, spectrum analysis, which is really what Chnalyzer specializes in, this is really important because with the use of the Wi-Fi, you can see non-Wi-Fi stuff as well. So not only can you see co-channel and adjacent channel interference with the spectrum analyzer, but you're going to be able to see this non-Wi-Fi stuff like, microwaves, baby monitors, cordless phones, things like that. Kind of what it looks like is like this. So Chnalyzer will perform Wi-Fi scanning. It's going to show you these neighboring networks here. But with the Wi-Fi plugged in, you're going to be able to see this type of interference here. So without a Wi-Fi or without spectrum analysis, you have no idea that there's some sort of major interference here on, kind of to the right of channel 11, just wreaking havoc on these networks here. And so it's really important to kind of have something like that to see the invisible. And just a quick note on Wi-Fi scanning, on Wi-Fi coverage. Chnalyzer will give you these numbers in terms of dBm, stands for decibels per milliwatt. It's kind of a quick note. It's really kind of important to understand what these mean. Typically, we like to strive for about -67 dBm for your network to achieve, good Wi-Fi quality. That's kind of the baseline that we like. Of course, if you're kind of streaming like Netflix or watching YouTube a lot, you might want better than that. You might want -65 at least throughout the house. -60, those are all really great signal strength. If you see -30, that means you're basically on top of your access point, which I'll show you here. I'm really close to my access point. As soon as you start dropping below -67 to around -70, -80, that's where you start dropping packets. Things are a little less reliable. And as soon as you see -90, that's just almost, you pretty much can't really function with that. And so it's really important to understand what this means. And Chnalyzer will show you these measurements for your networks. So we do call Chnalyzer the deep dive into spectrum analysis. It's a lot like Insider, but it really focuses on spectrum. And so with that, you can locate sources of interference, and I'll show you how to do this. And you can actually plug in a directional antenna. You can remove the omnidirectional antenna on your Wi-Fi and plug in the directional antenna to help kind of locate those sources of interference. There is a Wi-Fi scanner tacked onto it, so of course you can check for those Wi-Fi dead spots, and by dead spots I mean lower than, say, -80, -90 dBm like I just talked about. You want to make sure you have good, consistent coverage of your network throughout the environment, and Chnalyzer can certainly help you discover those things. And I think the coolest part about Chnalyzer, this is kind of the big differentiator between this product and other products, is that you can pause and rewind your spectrum data and go back and look at it. You can send your recordings to other technicians and they can look at it. Some people send recordings of Chnalyzer to our support team here at MetaGeek, and we can tell a lot of what's going on these recordings. So that's a pretty cool feature. And then of course, to really make you look professional, like you know what you're doing, you can build reports and hand this off to your customer or your client to kind of prove what you did, to kind of show what the spectrum looked like in the 2.4 or 5 gigahertz band. And I'll show you how to build a report as well in this. And finally, really cool thing is if you deploy Cisco access points that have the clean air enabled accessory or feature, you can troubleshoot remotely with the Cisco Clean Air accessory, which is also available for Chnalyzer. This is pretty cool if you have an office that's across the world or somewhere else and you can't really go to it, especially right now in today's world. You can actually troubleshoot that remotely, which is pretty neat. So, keep in mind that Wi-Fi devices, like I was talking about, are very polite when they see other Wi-Fi devices, and they still retain that politeness when they see non-Wi-Fi devices. So that's why it's really important to have a spectrum analyzer. I like this slide because it shows a microwave, and believe it or not, microwaves cause a lot of issues in the 2.4 gigahertz band, and Wi-Fi devices think that that's a Wi-Fi device, even though it's a microwave. And so, until your burrito's finished microwaving, all the Wi-Fi devices wait their turn to talk on the network if they see it. Here's some other examples. Baby monitors cause a lot of issues. This particular baby monitor actually kind of hopped from channel 5 here to channel 9. And maybe the network administrator switched his network to channel 1 to kind of remedy the problem, and then lo and behold, it goes and switches to channel 1. It frequency hops. So baby monitors are pretty notorious, and with a tool like Chanalyzer, it can really capture those intermittent sources of interference, because that's kind of what this is, intermittently kind of hopping from channel to channel, and that waterfall feature shows you that behavior, which is pretty neat. Bluetooth is really interesting looking, kind of actually looks like blue teeth. But, this is a ton of Bluetooth activity. Typically, you don't see this much. This was a lot of data being transferred via Bluetooth with quite a few devices at the same time. This would interfere with Wi-Fi, but typically Bluetooth is so fast and frequency hopping, it doesn't interfere with Wi-Fi, but it looks kind of fascinating. And then, of course, this is a picture of an old wireless analog video camera, which you don't see too often now that Nest and those types of Wi-Fi enabled cameras are a little bit more available. Instead of this kind of red spiky signature, it's now a Wi-Fi signature if you have a Nest camera on a channel, because video over Wi-Fi is still a very heavy bandwidth usage device here. And I see some questions coming in. That's great. I'm going to answer those at the end of this, but I see some good questions here that I'm excited to get to. And so, yeah, with that, I'm going to go ahead and open up Chanalyzer and just kind of show you guys some things, try and go over these bullet points, and then answer some questions at the end of this. So when you first open up Chanalyzer, it actually starts sweeping the 2.4 gigahertz band only. And so to remedy that, you actually go to Wi-Spy here at the top left and just select dual band if you want to see both the 2.4 and the 5 gigahertz band. So this will dedicate the resources of the Wi-Spy DBX to sweep both bands simultaneously. And so here we see the 2.4 gigahertz band. To toggle between the two, you just click the arrow in the top left corner over here. And so now we're looking at the 5 gigahertz band. Like I said, Chanalyzer is a Wi-Fi scanner, and so to see neighboring networks, you can just click this checkbox to see all the networks that you see. Now, remember how I said the 5 gigahertz band is a little bit shorter wavelength, so you can't see as much. So really, I'm only seeing my network's 5 gigahertz band here, and then I see one neighboring network over here on channel, looks like 150 or so. And I'm using a pretty decent network adapter. Again, this is a MacBook Pro booted into Windows, and they have really good, this little Broadcom 802.11 AC network adapter. It's pretty, I've been pretty happy with the antenna signal strength on it. But even still, I'm only seeing one neighboring network beyond my own network here. And so if I switch to the 2.4 gigahertz band, you're going to see a lot more networks, right? Just because that beacon travels so much farther in the 2.4 gigahertz range. And you can just see I have tons of neighbors on channel 1, channel 6, on channel 11, and I have a couple neighbors who are using channel, looks like 8 or 9 or something like that, which again, I wish I could go knock on their door and ask them to use 1, 6, or 11. Just to avoid the adjacent channel interference. But you kind of start to see what's kind of cool here. I'm going to get my annotation tool. You can kind of see this blue curve shape here, and that is indeed that DSSS modulation scheme I was talking about earlier. Just basic data rates, and that's what beacons are sent at. And so anytime you have a lot of SSIDs on a certain channel, you're going to see kind of that curve shape start to form just from pure beacon overhead. Just basically that every network on this channel is saying, hey, I'm this network, I support these data rates, you can connect to me. So it doesn't really look like too much utilization is actually occurring right now, just because I see nothing but blue spectrum. And so one kind of cool thing I want to show before I get into the spectrum analysis part is, I'm going to focus on the Wi-Fi scanning here. If I were really troubleshooting my network, I would remove the check marks from all these neighboring networks, and I would just place it next to my network, which is labeled Cathify. That's my SSID. And one really cool thing, if I were troubleshooting, let's say checking for Wi-Fi dead spots, I would use this networks graph over to the left of networks table. These are kind of all the available tabs here, and I'll go over a couple more of these tabs, but I highly recommend checking this one out. At this point, I'm kind of tethered to this desk, of course, but if I were kind of checking for signal strength, I would walk around with my laptop, and I have an access point just on the other side of this wall. And then I have a studio out back, outside, with an access point in that as well. And I'm able to see that beacon. That's what this beacon, our line, is down here. It's really distant. It's at -85 dBm. And so obviously, if I were trying to connect to that access point, I just wouldn't get very reliable signal strength or Wi-Fi. But of course, I'm really close to this network, this access point that's basically on the other side of the wall. And that's what these two radios are, my 2.4 and 5 gigahertz radio. So if I were to walk farther away and stay closer to outside, these lines would start to drop, and I could start seeing these lines drop just like that. Meanwhile, if I was getting closer to this access point that's outside, this line would start to kind of raise up a little bit. You kind of see, see how your network is, see if there's any dead spots, basically. And again, you kind of almost have to place an invisible threshold here. I'm just going to draw like a little dashed line at about -67 dBm. As long as you have signal above this threshold, this -67 dBm threshold, you should have reliable Wi-Fi. And so that's kind of the Wi-Fi scanning part of Chnalyzer. I think that's a pretty important part. But I want to go ahead and talk about Spectrum a little bit more and show you really how this tool shines. So right now I'm Etherneted in to my laptop, and because I don't really trust Wi-Fi, especially when I'm going to introduce this signal here. So I'm going to introduce some interference, and you're going to kind of see how Chnalyzer works and how it starts to kind of notify you of this interference. This is a significant interferer here that I just, we'll pretend it's intermittent. But right off the bat in this waterfall over here on the left-hand side, you can kind of see some activity starting to form. And the reason why I'm Etherneted in, by the way, is because when I've introduced this source of interference, it's actually kicked me off the network and kicked me off the demo or the webinar. And so I learned my lesson to hardwire my access point when I'm messing with interference and signal generators. And so let's just say this is intermittent. It's talking quite loudly over here. And if I move my time selector bar up to the last 30 seconds or so, you can just see bright red, right? This is a significant interferer. I'm going to say it's intermittent, so I'm going to unplug it for the moment. And just because that's really why Chnalyzer is really helpful, is because oftentimes the stuff is intermittent. It only happens at lunchtime or maybe at 8 p.m. Everyone gets kicked off the network and no one knows why. And I've just seen so many different weird types of interferers that cause issues like this. We'll say it's intermittent, and at this point it kind of starts to drop off now. But what's cool about Chnalyzer is you can always go back in time. I can just click and drag and go right back to it and say, okay, well, what is this thing? It's gone now, but Chnalyzer captured it. And keep in mind that when you open Chnalyzer, it's recording everything. And so it's pretty much saved in time at this point. And so Chnalyzer has some pretty cool features to help identify what this is, because maybe you have no idea what's going on here. If you click on the interferers tab down here, kind of to the very left, you can start to pull up what we call the signatures library. And with this, you can actually click and kind of drag the signature up to see if it matches. And so right now I have some 802.11b a signature here, and it's clearly not that, right? This is 20 megahertz wide. It fits more right here, right? And if you scroll, you can kind of manipulate the height of it, which is pretty neat. And so you can see that matches pretty well some 802.11b activity like I was talking about earlier with the DSSS modulation. Clearly not that. It's kind of fun to play with these signatures just to, if you aren't familiar with them already, it's really good to kind of know what they look like. Here's some 802.11g or N activity. It uses OFDM modulation, so it's a little more square shaped. Clearly not that, right? We have 40 megahertz if you're ever confused about, what channel width your networks are using, and you see the throughput, you can, put up a 40 megahertz wide channel, which is pretty neat. Here's that AV transmitter, Bluetooth that I showed you earlier. This part's pretty fun to mess with. So we don't actually have, this is a signal generator. The closest thing that I found it to be is this RFID reader. It almost matches that pretty nicely. And so at this point you can say, okay, it's something like an RFID reader. Now we want to find it. Maybe we're able to discover what it is. And by the way, if it is a new device, you can actually add signatures. You can actually add new signatures to it. If I were to let this run a little bit longer, this third option here where it says add new interferer identifier, and then you can add it to your library for future use, and you can actually share that with other people as well. Let's say that we don't know where it is quite yet. I'm going to reintroduce this source of interference. Starting to talk again. I kind of want to show you guys how to use the device finder. And so if you scroll up here and I'm just going to go back to real time. I just put my time span at the top left here to the last 43 seconds. You can adjust this as much as you want. I'm going to switch to 30 seconds. And let's just say we wanted to figure out where this thing is. So at this point, we have it, last 30 seconds. All you have to do is click and drag around the signature here, and you just click on device finder. And then you can kind of clean up your selection a little bit. And then you hit this check mark. And this goes into what we call the device finder feature. And at this point, you basically played hot or cold with the signal. So as it gets farther away, you attenuate the signal, that blue line goes down a little bit. That means you're getting farther away. As you bring it back closer, my Wi-Fi is over here, that blue line goes up higher, and that means you're getting closer to it. You can kind of see the interference kind of get taller as well. We keep a little window on the left-hand side of the interference. So it's actually pretty easy. And this is using the omnidirectional antenna, by the way. I'm going to go ahead and say we found it and remove the interference. This is using the omnidirectional antenna, by the way. The directional antenna is really good if you really have no idea where to even start. Let's say you're really far away from it or something like that. Then the directional antenna is handy, but oftentimes I recommend just trying to find it with the omnidirectional antenna first, because you can still walk around and kind of see where it is. And so right now we started a new session. I just removed that source of interference, and I want to kind of bring up how sessions work in Chnalyzer. Once we went into that device finder, it focused the resources on such a small portion of the spectrum that it no longer was sweeping around it. And so to go back to those sessions, you just go to View and Session Manager. And so this was the very first 2.4 gigahertz sweep that I did, and this was the second one here. And so I'm going to go back into the second one here, and sometimes you have to kind of click twice to get back into it. So here we go. So here's my my new waterfall. This was, again, a few minutes ago. It was for 8 minutes, and let's just say I wanted to build a report after not only identifying the interference but finding it. Let's just say I wanted to kind of prove what I did. And again, this is a recording that can be, if you go to File and Save As, and you have to be at the live one, so File and Save As. This will save everything that you just did as a WSX file, which can then be sent over to our support team if you guys want to get some advice on your network or what have you, or you can send it to a technician for further troubleshooting. But I'm going to go back to that section over here that had that those couple intermittent interferes here, and I'm just going to go to about right here. And one thing I want to show too is while this was interfering, while this interferer was talking so loudly on channel 5 and channel 6, notice the networks table down here. There's really only networks on channel 1 and 11 are really the only networks talking, and then of course those in the 5 gigahertz band, because it's completely separate. As soon as I select over here, you can see all those networks coming back to life, and I'll put check marks here. All those networks came back to life. Basically, for that brief moment, those neighbors, if they were using the 2.4 gigahertz band and those networks, they were incapable of using that network, essentially. The interference was so loud that it hid the beacons. And so I kind of want to maybe show that to a customer. So I'm going to go back and build a report here. I'm going to go nice right about here. This is a good little segment in time to showcase. I'm just going to go to Report Builder here at the top and click New Report. And at this point, you just click this little plus sign to add whatever portion you want to add at this point. Wherever your time selectors are around, that's what's going to be added. And so the first thing I really like to add is the density graph, which basically just shows, and I'll see if I can get this slightly larger for you guys. this basically just shows what the spectrum looked like at that point in time. And so what's really cool too is it pre-populates it with literature. Right off the bat, we kind of show the customer, we explain to them what the colors mean. So blue means less than 10% utilization. So blue is kind of like a clap. Doesn't really interrupt our conversation, doesn't really interrupt the webinar, but the Wi-Fi will still work just fine, right? You can still hear me, the conversation is still fluid. Green and yellow means 20 to 40% of the spectrum is being utilized, and then red means over 50% of the spectrum is being utilized. So red is a lot like an air horn. If someone were to come into my office and just blare an air horn right now while I was trying to give this demo or this presentation, it would interrupt it, right? You wouldn't be able to hear me. I would have to yell really loudly to get over the air horn. And so that's what this red interference basically represents. And so maybe I want to show this. Maybe I want to show the networks table as well, kind of to show off that this interferer was basically muting all networks on channel 6 and 5 and anywhere in between 1 and 11. So pretty small networks table here, and so that's good for now. I like this. And so let's go ahead and just select after we remove the interference at this point, and let's just go ahead and add a little. We'll do the same thing. We'll add another density graph. Now that the time selectors are around cleaned up spectrum, we can see that current snapshot basically. And let's just say, keep in mind, this is all editable. If you click the pencil, maybe we don't want to have the exact same literature that was in the previous one. So maybe we want to delete this. Or, you can add your own notes as well. But you can add whatever you want here, which is really nice. And then let's just say we want to add another networks table, because there were a lot more networks once I removed this interference, right? Now there's all those networks on channel 6, on channel 5, and so on. So pretty neat to be able to kind of show that. And I'm going to maximize this report so you can kind of see what it looks like in its fullness. And of course, you can export this as a PDF. You can save it and come back and work on it later, and someone else can access it. This is also a file that you can separately save and continually kind of edit and tweak. Makes you look really, really professional, which is pretty cool. I'm going to go ahead and just exit out without saving. So that's the report builder accessory, which again is pretty neat. I think that's mostly what I wanted to showcase for you guys today. I think those are some of the more important features of Chnalyzer. Let me go back to my presentation, make sure I covered everything. Yeah, that's pretty much. Oh, one thing I didn't show that I think is pretty neat as well is I'm going to go back to live here. A lot of people ask about site survey, and the big thing between site survey and our tools is that you can import a floor plan. Our tools, you can't import a floor plan. It's most post-deployment verification. However, there's kind of a cool workaround, which in my opinion, I think is important to know, and that is being able to add notes to the waterfall. And so at this point, we're live scanning, we're looking at the last 2 minutes. I'm going to go to maybe the last minute here. And let's just say I was kind of wanting to walk around the environment and get a good idea for what's going on. And I'm going to go in the 2.4 gigahertz band here. If you right click anywhere on the waterfall, you can add a little note to it. And I like to recommend customers add their physical location. So for instance, Casey's office. And then just click done. And then there's a little note there and a little kind of line that shows this is where I was, this was Casey's office. And then I can walk to another room and add another note and say, this is the bedroom, for instance. And this really helps us at the MetaGeek team. If you are submitting these recordings, this helps us kind of know where you were at. And we at this point, we're just looking at, normally I would kind of gather what network is the one I should be looking at, which in this case is Kathy 5. And I can kind of check for signal strength at each of these notes. And what I'll do is when I'm playing back a recording, I'll just go through maybe a minute or 30 seconds at a time. And I just look at the signal strength of the networks. And I keep an eye on the spectrum, of course, as well. And, kind of give advice based on that. And I'm really just looking again for that signal strength, negative 67 dBm. I'm trying to make sure that, things look good from that perspective. Let's go and get some more networks in here. Yeah, there we go. And so, I think that's a really important part, being able to add notes to the waterfall as well. I think that's mostly what I want to showcase. So I'm going to bring some questions over here and see what you guys had. I think you had a lot of really, really good questions. Let's see here. I see some questions about updating to 5.11, and we did just release a new update from 5.10 to 5.11, and 5.11 introduces Wi-Fi Air support. So if you have a Wi-Fi Air, which is a device that was more made for mobile troubleshooting, it will now work with Chanalyzer 5.11 and pull in spectrum, very similar to what you're seeing with the Wi-Fi DBX. Okay, Mart had a question, where do notes added to waterfall show up during playback? Yeah, you know, basically they show up, I think it's just this notes section right here, this actual tab. And so that's, you know, kind of mostly where I look. And then of course, you know, it kind of shows up in the waterfall when you have that selected with the time span. So I'm able to kind of tell based on the color which note it is here in the notes section tab. So good question, Mark. Okay, yeah, good. So let's see here. Avril had a good question about 6 gigahertz band. Notice at the beginning of the presentation, I said currently there's the 2.4 and the 5 gigahertz band that is mostly used. And it sounds like the 6 gigahertz band is coming, and it's coming pretty fast. I think it's slated for within a year. And so, yeah, you know, as long as MetaGeek is still a company that's, you know, we're dedicated to providing hardware and, of course, updating the software to display those bands. The Wi-Fi DBX is a 2.4 and a 5 gigahertz spectrum analyzer. You can get a little bit outside of those frequencies with it. I believe we're going to have to ship a new piece of hardware to introduce or to accommodate the 6 gigahertz band. I think the 6 gigahertz band is just too wide to be able to use the DBX, I believe. I'd have to check with our hardware engineers on that to be sure. But yeah, we most likely will have a hardware dedicated to, you know, it might be called the TBX, right? The tri-band spectrum analyzer, 2.4, 5, and 6 gigahertz. Again, we kind of need it to be a little bit more streamlined. Typically, we want to see some devices that are capable of using it. We want to make sure it's getting implemented in access points and things like that. In my experience, in Wi-Fi, stuff like that moves a little slowly, and so we should still have some time, plenty of time to iterate and develop a piece of hardware to sweep the 6 gigahertz band. But really good question, Avril. Okay, so Ahmed share some insight on SNR and noise floor. So yeah, that's a really good question. The noise floor is simply, you know, kind of, well, we should be able to see it here with the utilization here, this kind of low level activity. And again, we don't even have a crazy noise floor. If I introduce this interference, you'll see that noise floor kind of raise a little bit more. And SNR is signal to noise. And I can't remember the exact formula, but essentially you want your Wi-Fi network to have a certain SNR, which means I think it's like 40 dBm higher than the noise. When I introduce this interference, you'll kind of see the noise here start to populate a bit more. And so this kind of, you'll kind of see at about negative 95 dBm is about my noise floor here when I introduce this interference. There really isn't much of a noise flare other than that. It's at about negative 100. So my Wi-Fi environment is actually pretty clean here. But if you go to like an airport or something like that, you'll see a higher noise floor. And you know, the thing that I compare the noise floor to the most is like background noise. It's like when you have a fan on in your bedroom or something like that, and the fan is just constantly kind of sparking at this this level. And I don't know if if you have a friend or you know, if you're a partner or whoever you're living with, sometimes it's hard to hear them. You know, if their frequency, if the frequency of their voice is at that same level with the fan. And that's kind of the same way with Wi-Fi and noise floor. I really like to use those as an example. The noise floor is just background noise. There's a lot of it usually in higher RF environments. You can see the background noise here just start to raise due to this interference, which I'm going to go ahead and remove just in case neighbors are trying to use Wi-Fi. But you want to make sure that your Wi-Fi network is at, I think 40 dBm is the magic number above that. And so you can see here this Cathify network. If this interference here was right here, this wouldn't even cut it. This would need to be, you know, way higher for me to have a solid Wi-Fi conversation and a Wi-Fi network. So you want at least, I believe it's 40 dBm. I can't remember exactly. but your SNR, your signal to noise ratio, that a lot of Wi-Fi experts say that's the most important thing. So while I was talking about signal strength earlier in dBm and things like that, you know, negative 67 dBm, that's assuming you have a low noise floor. It might need to be higher if you're in a congested RF environment where that noise floor is elevated. If your noise floor is kind of hovering at like negative 85, you actually need more than negative 67 dBm to have a good, reliable conversation. So that's a good point. Okay, it looks like yeah, it looks like Olivier was saying that the target SNR is 25 dB. Yep, for 802.11 AC network. So I was a little over on that, but very good question. So I'm just scrolling through the chat now. I know we have a Q&A, and how much time? Yeah, we have quite a bit of time actually. So I'm going to try and spend as much time as possible on this Q&A section. So I answered the 6 gigahertz from Anders. Appreciate that question. Oh, okay, so I'm going to bring this. Over here so I can see it a little bit better. So when I'm talking about Wi-Fi range, is that considering US country code or any? If US, what about for EU? So for Wi-Fi range, I think you might be talking about signal strength that's, you know, pretty much universal across the board. The only thing that kind of differs from my presentation from the US to the EU or other countries is the non-overlapping channels in the 2.4 gigahertz band. In Europe and Asia, I believe it's 1, 5, 9, 13, I believe, are 4 non-overlapping channels in the 2.4 gigahertz band. In the US, we just a little bit different space in the 2.4 gigahertz band for commercial use. It's 1, 6, and 11 are the only 3 non-overlapping channels in the US. So yeah, I apologize for the EU and for the Asian customers. I believe that there is a different frequency space, particularly in the 2.4 gigahertz band for that. Eric asked if this is being recorded. Yes, this webinar is being recorded, and this will be sent out automatically to those of you who attended and to those who weren't able to attend. This will just be sent out automatically one day afterwards. So good question, I appreciate that. And of course, I will edit out the audio technical difficulties at the beginning. Let's see, Naveen had a question. I don't see networks tab to bring up networks drawn on top of the graph. Okay, yeah, good question. So one thing to keep in mind is, and I'm going to kind of put this back over here, to see networks, not only do you need to have a check mark placed next to them over here in the networks table, and so you need to have a check mark here. And we used to have a spot, depending on the version of Chanalyzer you have. This one is a little bit more updated. But there's some toggles up here in the top which shows you like the current trace, for instance, and I'm gonna take off the networks so that you can actually see what I'm talking about. There's an average trace that you can toggle on or off. You can toggle on or off the max trace, and this is helpful. A lot of RF engineers know what this stuff's all about. You can toggle off the density if you just want to see a current trace, but I like to see density in order to see things like this. For instance, if I didn't have density toggled, I would only see a current trace. There we go, which would look like that, which doesn't really tell me the story too much. I like the density to see how loud it was talking or how loud it currently is. But an older version of Chanalyzer, you would have to toggle networks on here as well. And so you might have an older version where you need to make sure networks is toggled on, and then you also need to place a check mark next to the network to see it. And if you're not seeing it, make sure you're looking in the 5 gigahertz band as well. You can still place a check. For instance, I can place a check mark next to this one called CenturyLink, but I'm not going to see it until I toggle over to the 2.4 gigahertz band because it's on channel 1. So Naveen, I hope that answers your question. Okay, what type of Sonos device did you connect for this demo? So I don't have a Sonos device. I was using a signal generator. I'm not sure if you guys can see this. I'm using a signal generator. These are pretty old. I think these are hard to find. I got this from the MetaGeek office because, of course, we need to have things like this to test out our spectrum analyzers. I'm not sure, honestly, where to get them because I think now that Wi-Fi has become, I mean, this is like pre-2004, 2005. Now that Wi-Fi is so much more mainstream than it was back then. I think it's hard to find devices that deliberately jam up the 2.4 or 5 gigahertz space. But I don't use Sonos. I know that's kind of a wireless technology that's common. We you know, I see a lot of Zigbee as well, and Crestron equipment and things like that. And of course, Chanalyzer displays that stuff quite nicely, just because they all talk on the same 2.4 gigahertz band. Let's see, Jason, don't see the network graph anymore. Let's see here. You know, and keep in mind that for the networks graph, Jason, keep in mind that for this, you do have to have a few networks toggled or checked. You do have to have a check mark place. So if I place check marks next to all my networks that I can see, I have kind of a messy coloration here. You know, I'll take a look and see if 5.11 changed anything. Right now I'm using 5.10 just because there's a couple stability issues that we're still working out here. So I wouldn't be surprised if there is an issue with the networks graph on 5.11, but it is important to have a check mark. And then white check are the colors representing time domain. It's basically representing how much the spectrum is being utilized. So kind of like I think I answered that a little bit later, talking about clapping versus the air horn, but red just means that 50% of the spectrum is being utilized, kind of like an air horn, and blue is just very light RF activity, light chatter. It's kind of like a clap. And then everywhere in between is in between that. So yeah, very, very good question. Can Chanalyzer be used to analyze airtime usage? You know, in terms of spectrum, absolutely. I think spectrum is kind of the say-all. You can kind of get a good idea of airtime with packets and packet analyzers, which, you know, of course, MetaGeek sells that with other products like Insider and IPA. You know, a true measurement of airtime is, in my opinion, you know, a spectrum analyzer. And so, for instance, if I run a speed test, I'm just going to run a speed test on my iPhone that I have right here, and kind of show you what airtime would almost kind of look like from a spectrum analysis perspective. So I'm just going to run a quick speed test, and you'll kind of see a little bit of activity, assuming that my device is on the 5 gigahertz band here. So yeah, you can kind of see that starting to form. You can see this green speed test. I'm getting about 110 megs down. Now I'm doing my upload, which is actually more. I'm getting 140 up, and you can kind of see what that looks like. In a sense, this is kind of the truest airtime, and you can actually go to the channels table, and I guess we don't call it airtime, we call it utilization. And so you can kind of get a good idea for the utilization on those channels, which of course, when I run a throughput test, I'm at about 25, and I'm kind of coming off the end of that throughput test here. Yeah, so I mean, I guess you don't get airtime in terms of a packet, but you do get utilization of the spectrum, which I think is arguably kind of a more true kind of understanding of what's going on. I can take a look at this and see that there's not a lot of airtime left on my channel 42 80 megahertz wide channel when I'm running a throughput test. If I were to do that on multiple devices, there would be a higher retry rate and kind of packet loss and things like that. So that's a good question. Let's see, Olivier, can you identify the device that's running on channel 40 at -33? Yeah, you know, it's funny, Olivier, that's funny you brought that up. I think that has to do with my adapter. I'm using a USB-C adapter. I was trying to figure that out yesterday. I know exactly what you're talking about. What Olivier is asking about is what the heck this thing is that's at like -35. It seems to be pretty constant. And if you look at my networks table, it's basically a hidden network that's really close. Let's see if I can find it. Yeah, it's right here. I've been trying to figure that out all day. It only happens in my Windows VM. I don't know if it's the adapter I'm using. I even used a packet. Nothing's connecting to it. I've been trying to figure that out too, Olivia. That's funny you noticed that, but I think it just has something to do with my current Windows setup. And I'm using an Ethernet adapter. I feel like that might have something to do with it. Otherwise, I really don't have anything else that would be broadcasting a network like that. So very good question, Olivia. I've been trying to figure that out myself. Maybe someone here has some insight on what that possibly is. John asked about, will Chanalyzer detect Wi-Fi 6? Yes, Chanalyzer 5.11 will detect Wi-Fi 6. That was one of the updates. 802.11ax is another name for Wi-Fi 6. And yeah, you should be able to see those access points now if they are. It'd basically be in this networks table here. it would basically just be displayed over here as AX. So good question. Let's see, can you review the new device settings in 5.11? Well, all I know, Richard, is that we've included support with Wi-Fi Air, and if you have issues, the Air should just be plug and play. You should be able to plug it into your laptop and it should show up. If it doesn't, we might have to get you the drivers for it, which are supposed to be installed automatically with 5.11. If you have any issues with the Air showing up in 5.11, just contact support@metageek.com and we can take a closer look at it and make sure we get you those drivers. We'll just send you the driver installation package. A little bit more about the integration with Cisco Clean Air, David. Yeah, so basically you do have to have a Cisco access point, of course, and not all Cisco access points have this Clean Air functionality, but basically from the Clean Air menu, you just need the IP address of the access point and the NSI key. We have literature on our support website, which is support.metageek.com. Highly recommend going there to figure out how to connect to one of these access points. It's pretty straightforward. I think we used to have one in the MetaGeek office that we would connect to test to, and it might still be there, but I don't recall the credentials for it. You do have to be running controller firmware that's past 8.3. If you run anything before that, it might run into some issues. And typically it works best with the Cisco 2800 and the 3800 access points. But you can kind of see how it looks here with this little accessory. So yeah, good question. Let's see, do you have a signature example for LAA or LTEU? In Chanalyzer, we don't. Again, if you come across something like that, feel free to send it over to our support team. Just give us a trace or a recording, and we can kind of beef up the signature library. I haven't seen a lot of, I actually don't even know what LTEU looks like. I imagine it would look something like this that I'm seeing right here on, I'm going to frequency zoom here. I'm going to go back to live. Typically, I've seen cell phone towers kind of look like this little spike that's really small. Typically, that's what I say. Again, I don't know about LTEU specifically, but typical cell phone towers are just little small spikes like that. They're maybe like 5 megahertz wide, if that. And they kind of look like this, and they typically operate in non-Wi-Fi channels to not interfere with Wi-Fi. But of course, that isn't always the case. And it looks like even in my current environment, I'm seeing some real distant kind of things like that could be cell phone towers, that could be airport controllers, things like that. I've seen a wide array of things like that, and they typically look like these little spikes. And this is a good example of I'll just do a frequency zoom. Granted, this is it's going to kind of be pixelated, but it just kind of, this is really far away. This is obviously quite a ways away from my house. I'm seeing about -90, -80 dBm, but it's red, right? So it's something is talking very loudly in that very small space. It would look something like this. If I were closer to the tower, I could kind of zoom in and get a more clear signature. But most cell phone towers look like this. And then in terms of client devices, I'm not sure what that looks like. It uses a different frequency typically than the 2.45 gigahertz band. So I'm not sure if you could catch it with the Wi-Fi DBX. So I see some questions about Mac will not work in a Windows box. I'm currently running this in Windows, but I'm on a MacBook Pro. I booted up in Windows using Boot Camp, which I really recommend if you guys are Mac users. I know I'm a Mac fan. And to get the best resources and to not need to use an external Wi-Fi adapter. Right now I'm using the internal Wi-Fi adapter in my MacBook Pro. I recommend just booting directly into Windows via Boot Camp. You can also run it in a VMware, but you would need an external Wi-Fi adapter for that. So good question. I see another Steve, you asked about Chanalyzer for Mac. I think the future is going to be more, if we have more Mac products, it's going to be Insider. That's what we're focusing on right now, is Insider for Mac. Chanalyzer is such a specialty kind of spectrum analyzing tool that I could see it staying in Windows for the time, and then maybe we'll kind of port some features of Chanalyzer over to the Insider version, which would be for Mac. That's kind of my ideal state. I would love to see, for instance, this waterfall view. I'd love to see this in Insider, and therefore for a Mac, I would love to see something like that. But you know, keep in mind we have a limited engineering team, so we can't crank out the Mac products as quickly as I'd like to. Let's see. Wojciech had a question about WiSpy DBX, and I only got a couple more of these. I don't want to keep you guys for too long. I think I just slated this for an hour. WiSpy DBX more than 5 years ago. Is there a reason for me to upgrade? Unless you want mobile troubleshooting, so the ability to use a mobile device, that WiSpy DBX should still be pretty much the same as the current WiSpy DBX. We haven't changed it a lot over the years. It should be pretty much the same quality. It still sweeps the 2.4 and 5 gigahertz band quite well. Only if you wanted to use our AirViewer application on mobile devices like iPhones, iPads, Android devices, then I would consider getting a WiSpy Air, which is kind of a new product from MetaGeek. But if you're happy troubleshooting with a laptop device, then I think it would be good to consider just keeping that WiSpy DBX. Okay, last Q&A question from Reno. Why don't mesh sets and routers follow channel format 1, 6, and 11 by default? That's an awesome question, and that's posed often in the Wi-Fi community. I guess the least harsh answer to that is simply those vendors typically don't, I don't want to say they don't know, but I just don't think it comes across that they should only designate 1, 6, and 11, and especially too for, let's just say, our European and Asian customers, where 1, 5, 9, and 11 are the 4 non-overlapping channels. Those obviously need to be included, but typically it's just, you know, typically APs just kind of send out access points and they don't really, you know, engineer too many smart things like that. I think it would be awesome if they only deployed, let you deploy 1, 6, and 11 in a US access point, for instance. But you know, it's just not a reality. There's kind of a lot of other things as well that access point vendors could do to make it smarter. For instance, you know, if they do have auto channel selection, only select channels 1, 6, and 11. I've seen auto channel selection select 5 and 7 and 3, which clearly are the worst, you know, possible choices for a certain Wi-Fi environment. A lot of them don't have smart spectrum sniffing capabilities, and so you know, and for instance, Eero, I think is a good example of maybe why you're asking this, Reno, because Eero will deploy a 40 megahertz wide channel in the 2.4 gigahertz band, which just opens it up that much more to adjacent channel interference. It's a big no-no typically in the Wi-Fi community, but they do say, we had a conversation with Eero about why they do that, and they do say that if they see too much noise in that 40 megahertz wide channel, it will shrink back up to 20 and use 20 megahertz only. So, you know, they claim that they will kind of, you know, kind of self-mend and kind of shrink back up to 20 if there's too much interference. But I know I've deployed Eero before and been like, oh, I wish I could just keep this at 20. I know for a fact that it's not a good environment for a 40 megahertz wide channel. So I do wish that they would give us a little bit more options to do that. And it would be nice if they were smart enough, but it's a really good question, Reno. But yeah, I just think that we're just not quite there yet in terms of engineering super smart access points. So I know we have a couple more questions in the chat. I'm going to go to the very bottom and work my way up because I won't be able to get to everything. Okay, yeah, Davoud said they use 1, 6, and 11 in EU as well, which is awesome. Do you see radar detection in Chanalyzer? That's a really good question. So keep in mind that, and I apologize, I'm going a little over, but I did have a few minutes of audio difficulties at the beginning of this. And so regarding DFS channels and radar detection, typically that stuff moves way too fast for Chanalyzer to see. So, you know, keep in mind that DFS is, you know, about 100 to like 140 or so. So this area right here, we can certainly, you know, if it stayed on the channel long enough, we could see it. But typically DFS events and radar events are so fast, it would just be a quick spike like this, and it might be gone before the WiSpy can even sweep it. kind of ways to possibly catch it if you really wanted to would be to do a frequency zoom and dedicate the resources only to this area. And again, I'm just going to go back to 5 gigahertz here. And you can actually, if you go to YSpy, you can actually just default to DFS. So I'm going to go to Uni 2 here. Actually, let's just go to Uni. Here we go. This is where a DFS event would occur. And so right now I'm dedicating all my resources to it. So this would be my best bet to catch a DFS radar event. You might catch it, you might not. It's so fast, and it's obviously on purpose why it's so fast to be able to catch those things. So good question. Typically you can't catch it, but if you were sweeping and dedicating your resources to only these channels, you might be able to catch it. Let's see. So Matt says, is it better to stay at the lower channels, assuming they're not being used, than the higher channels, or does it not matter? If so, then why? So we're talking about channel selection here. I'm going to go back in Chanalyzer and go back to the full dual bands. And so it depends on what band you're talking about. Keep in mind that in the 2.4 gigahertz band, it doesn't matter, you know, as long as it's clear from your neighbors, 1 or 11 are, you know, the same. It doesn't really matter, in my opinion, too much if you use a lower one or a higher one. Now, when you go to the 5 gigahertz band, there's just a couple things to know about using DFS channels that we were just talking about. This channel range right here, I typically don't recommend deploying networks in, just because Doppler radar events occur here and access points have to switch to another channel if you are on here. And not all devices are compatible with this band. If you go to, I think it's Michael Bono has a client list you can Google. And, you know, for instance, Amazon Fire Sticks, I think some generation just doesn't operate on these channels. It just simply won't connect to an access point if it's deployed on these channels. You would have to use something over here. So I typically recommend using 36 through 64, 149 through 165. If those seem to be completely used up, then maybe start considering using 100 through 144. But I typically use those ones last to avoid DFS issues. So good question. That's just a little bit on channel selection. That was from Matt. I'm going to go up, maybe answer 1 or 2 more questions, then we'll have to call it good. I'm going over already, so I appreciate all the questions here. I appreciate everyone joining this webinar. And I apologize about the audio issues. I'll have to figure that out. It sounds like a kind of a Windows thing here. Paul asked, do you have an Xbox One? I had the same issue. Oh my gosh. So I think we figured out the issue, Olivier. This might be my Xbox One controller, which is actually right here. Maybe that's what it is. Maybe it's my Xbox One controller. Paul, thank you for that insight. That could very well be what's going on with that channel 40 hovering at the exact same static -35 or so dBm. That's fascinating if that's the case. I can't wait to do some more troubleshooting with that. And it's very interesting that it shows up as a Wi-Fi network. But unless Paul, you're talking about this little spike here, which maybe it's that too. But indeed, I do have an Xbox One, and maybe that is what it is. So that's fascinating. Wow, just learned something new from you guys. I appreciate that. Let's see. I'm going to answer 1 more question, and then probably have to call it. Okay, so let's see, Felipe, any considerations using Chanalyzer with virtual cell solutions, Fortinet, Maru? I'm assuming you're talking about more integrations like the Clean Air. We've talked about working with other AP vendors. Cisco just seems to be the most kind of broadly used in terms of spectrum sniffing. We've certainly talked about getting, you know, Ruckus involved. Arrowhive would be cool. Kind of tapping into the access points a little bit more, but we haven't developed much more beyond Cisco. So that's a good question. And okay, so last question, Brian asked, omnidirectional antenna to use for 2.4 and 5 gigahertz, any recommendations? Yes, we use what's called the Alpha APA SM20 or M25. So APA M25. It's perfect, actually. It's RP SMA connector. It's 2.4 and 5 gigahertz compatible. For you older customers, you would know that our previous directional antenna was only compatible in the 2.4 gigahertz range, but we've since moved on to the Alpha APA M25, and that supports the 2.4 and the 5 gigahertz band. So that's the model we sell with the Chanalyzer Essential Bundle. And again, I didn't mention this, but right now the Chanalyzer Essential Bundle is half off. We have a Crush Corona 50 discount that's automatically applied. So now's a really good time to purchase these tools if you haven't already. I know most of you are probably following along and have already purchased the tools, but I should mention that it's currently 50% off, and I don't know how much longer the sale will last. We can't keep it going forever, of course. This may be the last week. There may be another week. I'm not sure. It's kind of day by day at this point. So now's a good time. If you don't have Chanalyzer Essential already, check that out. Again, this webinar was being recorded, and so it will be sent out to you guys via email. We're just at about time, and it'll get cleaned up and everything, but be on the lookout for that. Again, thank you guys for joining. You know, if you have any questions, I really recommend reaching out to support@metageek.com. We have a community section as well. Community.metageek.com is the URL for that, and highly recommend checking that out. It's kind of cool because people are kind of self-serving on the community right now. And if we can't get to it as MetaGeek support agents, some people are answering questions for customers, which is pretty cool. So again, thank you guys so much for joining, and take care, stay safe out there, and we'll see you for the next webinar. Take care, guys.